The topic is about a deep learning based multi-source satellite data fusion. On going deep into the topic, the satellite data fusion analytics based upon the multi-source simulations, unlocking the unparalleled insights from Earth observation data through the fusion efficient. The challenge divert satellite data complex uh, Earth observation satellite generate an enormous volume of desired heterogeneous data that includes optimal radar and multispectral, temporal, and series information, each with unique characteristics and limitations. Optimal data affected by cloud cover the daylight, radar sensor, and providing all weather the imagination through the suffer both spec and noise. Radar system that evaluation data log spectral information. The traditional fusion methods and often struggle with the complexity of sheer multi-data integration limitation of effectiveness and scalability through the comprehensive Earth observation. Through this, the different diverse factors of data analytics through the complex Earth observations and having the different types of multispectral limitation and unique characteristics limitations, which is also confound with the series information and includes the heterogeneous data, live data, and lacks of spectral information through the noise of sensor and affected by the cloud cover in daylight. Why fusion matters. Unlocking high resolution, high frequency insights. What is high frequency insights through the high resolution? When the unlocking of high resolution takes place, the frequency captured in the rare world Randstad is also having the trade offsets of insights which mobilates the high frequency method and overcoming trade of signal satellites are limited by inherent between the temporal resolution fusion combines and complementary data overcome these limitations. Enhanced applications enables the environmental monitoring and urban mapping, delayed agriculture analysis and rapid disaster response by providing more complete picture. Real world example combining a land stand of 30-meter 16-day across the 500-meter spectral and for significant enhanced vegetation monitoring. The vegetation monitoring enhanced the application of overcoming trade-offs. Deep learning AI game changer and multi-model satellite data fusion. The advanced compatibilities, deep learning models including conventional neutral neural networks, generative networks, and having transformers which leading data representation across within the diverse data sets. Superior performance. These model constantly underperform traditional algorithms by efficiently handling heterogeneous data source and extracting richer and meaningful features of combined datasets. Key breakthroughs through the significant advancements included enhanced temporal fusion of the techniques which are used in Siemens integration and optimal radar data system, which is having traditional algorithms to efficient handling heterogeneous system through the process of interrupted satellite data. Case study urban mapping with deep learning and data fusion. The Italian well detailed study shows that the deep learning fusion of RGB, orthophases, orthophotos, and data surface model create an orthophase through orthophoto and consist 4-band dataset. Deep lab schematic segmentation accurately captures detailed building footprints, appropriate accuracy and boundaries, which is across the compared conventional methods, accuracy improvement, boundary refinement, and training time reduction. These all help us for the segment of accurate captures detailed building profits. Advanced models in a spatimoral fusion stream and beyond. The stream beyond over variant high speed control over the temporary resolution and lower high temper resolution data. The advancements enables the generations and high resolution difference ve- between the vegetation index and time serial, crucial agriculture and monitoring, DL enhancement, deep learning, the CNCs, and having especially complex heterogeneous landscapes, which is traditional method of surge impedance and highly view of dynamic supporting for sustainable energy management and land management, which is across the DL enhancement, deep learning, and having high resolution techniques of vegetation determination and agriculture economical monitoring. These are the advanced model of spatial fusion and and beyond, where it is defined as adaptive reflectance of fusion modeling in further high spectral or low temporal resolution data, and having the special high temporal data resolution is also a DL enhancement. It comes under the DL enhancement. Integration optimal optical radar and LiDAR towards holistic land monitoring. Optimal data offers which spectral information and land recovery classification, vegetation health, and but it is highly susceptible to cover atmospheric conditions. Radar provides all weather day and night imagining compatibilities and making it into different monitoring areas which presents the cloud over often noisy. The data enhancement and alleviation measurement and detailed 3D spectral information. According to the crucial and modeling the forest inventory, but it is limited to spectral content because the data does not support the optical management of radar system. The DL fusion, which is having the deep learning fusion, harmonizes these diverse data sets, overcoming individual optimal sensor reboost comprehensive landscape. These landscape are also having the holistic land monitoring system where we can integrate the optimal radar and different types of inventory limited spectral content, which is having SAR. SAR means it is a radar compatibility, monitoring the areas of cloud often noisy. Emerging applications and impact: air quality mapping, high resolution PM 2.5 pollution mapping at 100 meters hourly scale, which is having 300 D of net fusion satellite grounded data. Soil moisture estimate up to DL 1 by 2, having soil grids planning, agriculture planning, and disaster response and planning of satellite data, better decision making for comprehensive fused satellite versions. Challenges and future directions are data holding, managing massive heterogeneous data sets with inherent uh, imbalances, the limited label data significant hurdle. Real-time process and units that the real-time fusion algorithms, rapid discussion making, time critical applications, integrations, seamless integration, which is geospatial big data platforms, and enhancing AI explainability, which is having like a greater adaptation of critical sectors. In general, the critical sectors generalization of capability across diverse geographical regions and the different sensor types of crucial border applicability. Applicability means the use or the requirement which is exist for consuming purpose. Conclusion of deep learning comes under transformative impact across sectors towards smarter globe monitoring. This technology enables groundbreaking applications in environmental science, urban development, and agriculture and public health, more informed through sustainable future. The future of the Earth observation, hygienes, the development and of scalability, interpreted our real-time fusion systems powering smarter global monitoring and accelerating significant discovery, which is having impact across all the sectors. The conclusion of deep learning unlocks the full potential of satellite data. Thank you.